Okay, it's recording right now. Great. Okay, today we're gonna go through all the pandas, and I hope data visualization as well. This is the previous tutorial file you had before. Okay. We had a very comprehensive review of NumPy arrays, and today is going to be all about pandas. You have to know that pandas is a open source library just built on top of NumPy. So there's a lot of common feature inherited from NumPy, and someday, like I think in 2008, a guy was so sick and tired of working with time series in R. It was very difficult. So this was the main motivation behind designing the pandas library. Pandas is just like NumPy, very fast, very efficient for data manipulation. And it also stands for data panels. So Panda panel data. There is three different type of data in pandas, which is series. Series are one-dimensional. They are data frames. Data frames are two-dimensional, and we have also panel. Panels are three-dimensional, and we're not going to touch panel in this tutorial. Mostly about data frames. And what else? There's also another different thing between NumPy and pandas. Although they're very similar, the only thing is that in pandas, you have the ability to keep different types of items, like data types. So you could have integers, floats, Boolean, even Python objects all together. So it makes it very, very useful. So in pandas, you work with complex data structures that have different type, and they are mostly in the shape of tabular data. So they are labeled and they are tabular. First of all, just like what we did before in NumPy. Sorry. Okay, just like what we did before, we need to import the library. So here, we had a very brief introduction about Panda. We need to install Panda. For most of you who are working with Anaconda, it's basically installed. There's no need to run this syntax, but in case you need it, you could do it. I mentioned that there is a difference between Conda and pip. They are actually doing the same thing, but Conda is recommended more because it could handle all the overlaps, but pip sometimes have some bugs. So I need to install it and then import it. And I told you before, there's a need for putting a name for your package. And from now on, I'm going to call pandas like PD, and all the other function and method needs to be called by PD alias. Okay, the first data type in pandas is series. Series is basically a labeled NumPy array. So they are very similar with NumPy array. It's a one-dimensional array, but they are labeled. So I have it here. I didn't have a lot of description for a series in my initial file, so I put it also here, and I could maybe share it with you later. So in series, the syntax is like this: panda, that's series. There is two important argument input here. The first is the data you have. You have the data that you're going to change it to a panda data. Okay, and there is also a second argument, which is index. So here I have an array of random values with size 5, I'm going to change it to a pandas series. This is my pandas series. So this is a one-dimensional array, just like what we have in NumPy, but it's labeled. So each item has a label. It is called actually index. And this is what I pass through my syntax here as my second input. So I'm passing an index, and if you pass an index, it's going to get the value of your list. Otherwise, if I didn't do that, and it's actually the same for data frames. So if I didn't do that, it's going to label my data entries from 0 to 4, which is the length of the array minus 1. Okay? So this is going to be a series. And there is also a feature here, which is data type. It's telling me that the data type of all your items in this series is float. So there is one good case for using series, which is time series, basically. So in time series, you have a lot of points of time and a value, different values, like demand of a product. Okay, so it could be stored as series in pandas. And so there's a data type, and I told you that you could define the index, and you could also call the index with this syntax. See, you could see the index, and there's this method. There's this method here that you could see the array. See, this is indeed a pandas array, but very similar to a NumPy array. A list of items with a predefined data type. Okay. Okay. In order to is anyone going to tell something? Okay. In order to create a series or a data frame, so we had two inputs. There was a data and index. The data could be different things. For example, it could be NumPy array, it could be a dictionary, it could be even a scalar. So this tree works for a series. Look here. So my first input was a NumPy array. I changed a NumPy array. I'm sorry. I changed a NumPy array to a series, pandas series. Now I can change a Python dictionary to a panda series. This is my dictionary. And dictionary is a very common data type in Python. In dictionary, you have keys and values. The first part are keys like A, B, C. And the second part is values. So this is the form of my dictionary. And whenever you're going to define dictionary, you need the exact same syntax. You need brackets, you need a key, and the values, okay? You can also see your keys with this function. These are the keys of your dictionary. You could also extract values like this, okay? So I'm going to change and convert my dictionary to the pandas series, and this is what I get. Look at this. So it's a one-dimensional array, but it's labeled, and the label are basically the index. If you don't pass the index, it would be an ordered list of dictionary keys, okay? But if I pass an index, it would change the index to what I want, like this. And if it's on a scalar, it literally repeats the scalar for all the entries, for all the data entries, okay? So I'm not going to describe this. Oh, here. I can reach to any values by calling the index. So each index in series is associated with just one value, but data frames are different, and we're going to see that. Okay. Now, what is the second data type? Data frame is a second data type. We're going to see a lot of them. And it's actually a two-dimensional labeled data. So it's designed to work with any kind of tabular data, like SQL table, or any dictionary, or even nested dictionaries. So you could work with two-dimensional data, and this is the most common form of data that you would see in practical data sets. It's float 64. 64 is for the number of bits that is going to take in memory. So a float 64 is basically need more memory than float 32. You also have it for integer 32 and integer 64. And it has all to do with how large is your number. Okay. So back to here. I was telling that data frame is the most common form of data you would see in future when you are going to practice with the data sets. Why? Because you have a lot of data points. Each data point is a row in your table. And there's also some features when you're going to work with a machine learning model. There are also some features, and each feature is associated with a column. So basically, you have data points, which is rows of the table, and you have features that are columns of your table. Okay? We can define this table with a dictionary, and we can also define with a NumPy array. So it is just like what we had in series. We could have different sources to convert to pandas data structures. Two of them are NumPy array and dictionary. So you can see I have a dictionary here. My dictionary has two keys, 1 and 2. And what is the value of my dictionary? Interestingly, it's a series. So you know that in dictionary, you could store anything. And I store here 2 series. And the interesting thing is that my 2 series has different dimension. There is 3 value here and 4 value here. I'm also passing an index for each series, okay? So there's, again, 3 index for this and 4 index for this. And now that I'm creating the dictionary and giving this dictionary as the input, as my first input, to Panda data frames. So this is the syntax for creating Panda data frames. See what I have. It is a tabular data with 2 columns. So what changed to column? Keys of my dictionary. So always keys would convert to columns. Columns are features of your data. And what are the rows? Rows are data entries, are data points, are instances. For example, you have reviews of people over different products. So each people has a review. Each people would be a data points. And also the features are here, the columns. Okay, so we saw how we change a dictionary to data frame. There's more examples here. I told you about how we could get values and keys from dictionary. This is what I did here. And now I'm changing data frame. I'm changing data, which is a dictionary, to a data frame. I'm also indexing it. Let's see the output here. I have 3 columns, 3 features, A, B, C, and 4 data entries, 4 samples, 4 data points. You could refer them in any different formats. In machine learning, they're calling this feature, they're calling this like predictor, and these are data samples. Okay, so if I'm going to reach a column here, I could do this. This is going to give me a column, the column associated with this feature. Okay. It could be also a list of more columns. Okay. And you're going to see a lot of different more filtering options as we move on. Okay. And this is another example. I have apples and oranges and something related to this. And this is my data frame. So we saw that there is a key and value. Key are the columns, and the value of the key is the title of my column. And we had value, and the value are associated with each item that it's for any data point. Okay.
I do have one question.
Sure.
So you mentioned that, for instance, it creates values based on the, I don't know, based on the on the keys and the list. But what happens, for instance, if you have an data set that is missing a value, for instance, for a specific feature?
You
What
saw
happens?
that here. I got you. You saw that
Okay.
here. I deliberately create an array with two different dimensions, and it was null.
Okay.
So this is what it automatically do.
Okay.
None.
Got it.
So it's basically the union of all the columns, and it
Okay.
includes none automatically. Okay.
Good.
So
Thank you.
that's fine. So here, I told you I could just eliminate this index because it's going to be 0 to 3. But if I give it the index, it's going to be different, like here. I'm going to record this data as the information that people gave me. Like June has a record for Apple as 3. I don't know what's the interpretation of the number, anything. Okay, and 0 for oranges. So this is my new data set. Okay, so you could label it in any way you want. Now, I can access, we saw how we could access a column just like dictionaries, that you call dictionary value by the key. So as I told you, keys are converted to column name. So you could extract a column by calling the column name, like here. Like here. Okay. Here, with the lock, I'm going to extract rows. So there's also another function, iLock, that we are going to see more example of in the following. So here, lock is basically giving me the row associated with this person. So lock, the input for lock is the name of the label. Okay, so it's the index name. You give it the index name, and it will show you all the numbers associated with like June. So it's apples 3 and oranges 0. And could you guess what is the data type of this? Do you have any idea?
It's
Yeah.
integer.
I'm sorry?
Integer?
No, no, it is integer. It is in integer 64 for each of the item. But my question is, what is the data type of the whole thing you're seeing here?
Tuple?
Here?
String?
No. See, what is purchases here? It's the Panda data frame. Okay, So I'm asking about data type of the whole output. Okay, so for purchase is a data frame. But now what? Now that I'm filtering or extracting a particular row. So it's a one-dimensional.
Yes.
Series?
Yes, exactly. That's a series. So union of series would form a data frame, right? Series are one-dimensional and data frames are two-dimensional. So if I take type here, that's the pandas series. Okay. I'm just insisting on this because sometimes if you know how it really works, it makes easier for you to remember. Okay, so one important topic is how
Sorry, I have a doubt here.
okay,
So the D type I saw was it's int 64, right?
yes,
So why is it not int 32? Why is not taking 32 bytes? It's the default size, right?
you're mentioning data type of purchase or here,
This one, yeah.
this one. You're asking the question is that why it's not integer 32?
Yeah.
Yes, it could be. It's the default. It is exactly the default data type that Python choose by default. I could generate my series and I could give it the data type as the input and force it to be integer 32. I mentioned it in the previous session that one of the good things of NumPy array is that you can define the data type. You can give it as an input. If you don't give it, so there would be a default for it based on what Python choose. Okay? But if you give it, it's gonna change.
Okay.
Okay. For example, you have a data and you know there's no need to allocate a lot of memory to it. Your numbers are small. So you're going to choose integer 32, not 64. Okay. And just pay attention that this data type is the data type of any item here, not the whole structure. This was my point. Okay. There is something. I'm very sorry that you people are waiting in the waiting room. I'm very new to this. I'm sorry. Okay. Here's one thing that it's very essential to know how to read from CSV. CSV files has a exact tabular form that we are talking about. There is columns of data and we need to read them and change them as a data frame. So this is the exact syntax. I have a note file just like this, just like the data set I have here. And maybe it's good to see it. Where is I? I can't hear you
And
anymore.
also in the link which you shared, I can't see the Python file. I can see only the CSV file.
Yes, it's a CSV file. Yes. The Python file, if you're mentioning the file that I'm going to, do you have a question on it?
No, I mean, we didn't receive the Python file yet.
Okay, yes, I was explaining. The file that I'm going through is on Moodle. The notebook, the Jupyter notebook file is on Moodle. What I sent you before is the CSV file. Okay?
Okay, got it.
Great. I have a text file here. I just wanted to show you very simple CSV file that I hear. So here, this is the name of the column and the value associated with each column. As you see, there's no index here. So what we normally do is this. You could ask Python to put an index for it. So if I says index true, it's going to assign an index to it. Okay. Otherwise, maybe my latest file have index, but otherwise, if you don't give it the index, it's gonna be again 0 to 4. Okay, but in my other file, I have changed the name. So if I change the name, and I mean if I give it a column as index, so I would have 3 columns in my CSV, and I will tell to put the index in my data frame. So this is the result. Okay, but if I didn't do that, this is my data frame. It considered my index column as one of my initial columns, not as an index, while it wasn't what I meant. I want this name to be indexed. So if you're going to do that, you need to pass the index as true. It's a Boolean input. Okay. And if it's like this, you could simply change the index column. You could ask Python to put the very first column with axis 0 as your index. Okay, because it's difficult for CSV to consider which column is actually your index. So this is how it's done.
Ziva, I have a small doubt here. Is the df is a special variable here, or we can name anything?
I didn't quite catch you.
Is the df is the it's a special variable, or we can name anything here?
The df, you can name it anything. It's only a name.
Yeah, I was thinking it is a special variable. We have to put it.
It's my data frame. It could be my df, my underline df, df1, df2. So it's the name of my variable, and my variable is a data frame, and I'm reading it from a CSV file. Okay. You can also work with JSON files, but I'm not touching it. I just want you to know that you could do that. And another thing is that after doing all the manipulation and all the calculation, data pre-processing, you could convert it, you could write it on a CSV file. So this is 2CSV. It was read CSV, and the syntax for it is 2CSV. The input would be your text file, and this is functioning just like before. Do you need index or not? Do you need to convert index to the CSV file or not? Okay. This is why I did it before, because see, if I do this and open my file again, you could see indexes. Okay. But otherwise, no. Back to here. Now it's time to work with a very important data. It's a real data showing all the IMDb reviews of many movies. So in the first column, you could see title, and title is a part of your data frame, but I choose to put it as index column. This is why you see title a little bit lower than the other column's name. It means that this is the index, okay? The name of movies. There's other columns that showing different properties and features of these data sets. For example, how people rate it, like what is the genre, what is the director, a brief description of the movie, and so on. Okay, so I gave you the CSV file. You need to put it as the input and pay attention. It should be in the same directory. For me, it is exactly in the same directory, so I didn't need to give the full directory. I just put the file name. And here I'm asking to put title column as my index column. Now I have my data frame. My data frame has 1000 rows and 11 columns. In what other syntax I could reach this information? Do you know?
Info. We can use.
Info is different. I just would like to know about the dimension of my data set. I wanted to know how many columns I have and how many rows I have. Too simple.
Can we use shape?
Exactly.
Function?
Exactly. I told you there is a lot of feature inherited from NumPy. So simply shape. And it's very important for you to know the shape of your data set, how many rows you have, what are the columns. Okay, so I loaded a CSV file. I deliberately choose the title, the movie title, to be my index. And now I'm going to extract a lot of meaningful information from this data frame. First one is head. Head normally give me very few first line of the data frame. It's very important to see your data sets, because normally you face a very huge data set with a lot of data and it's difficult. You could see that Python itself will do the job for you. It will extract some of the few line from the beginning and from the last line, from the last rows, and show you. But sometimes you want to see particularly first 5 rows. And this is how you do that. Maybe you need to see 10 first rows. Okay, we have the exact same thing for the last rows, which is tail. Good. Now we have info that some of you mentioned. Info gives a very general information about the whole data, like what are my columns and how many non-value I have. What are the data types of each column? Remember, each column is basically a series, a one-dimensional array with a specific data type. So you can see in the 10th column, or column with index 9, you have some null value here as well. Okay, so you can use info to have a very general understanding. And this is the shape I mentioned. Okay, one thing we need to do is to handle duplicate values. Sometimes there are some rows because there is operator mistakes. So you need to eliminate all the duplicates. And how you can understand that, I deliberately append my data frame to my data frame to generate a lot of duplicates. So remember, it was 1000 rows. I'm generating 2000 rows that all of them are duplicate. This is what I'm doing here. Okay. And when I get the shape, so it's double, I'm going to drop all the duplicates from my data frame. And remember, when I do that, I'm not going to touch my original data set. So I'm copying in another data frame, temporary data frame. And now I need to drop all the duplicates. So see what happens. It dropped all the duplicates, and the output is my somehow initial data frame. Okay. something very important here. If you want to do this every time and copy it in another data frame, you're going to waste a lot of memory. So they were visor, and they were put a parameter, a keyword argument, like in place. If in place is true, it's going to remove duplicate and save it in the same original data frame. Okay, so if I do that, it will eliminate and save it in my original one. Got it? But if it's false, it's not going to save it. There's no impact on the original data frame. You need to store it in another data frame. There's also another good parameter, which is keep. You could give this keyword argument in your function always. So what keeps do, it's asking what duplicate value I'm going to eliminate. Is it the first one? Is it the last one? Or it's false? If it's false, be careful. It's very bad. It's going to drop all of them. So if I like do this, keep false and in place true. So I'm dropping duplicates. I'm saving all my change in my initial data frame, and I'm not keeping any duplicates. So the output doesn't have any rows because it was all duplicates. Okay, so just be careful with the value of your parameters. Okay, there's also sometimes a need to drop a column or maybe add another column. This is first how we extract the column names from our data frame. I showed you before how we extract the values of a specific column with giving the name, just like dictionaries, and how to change it to an array. Okay. The data type is here Panda array. I think there is a difference between this array and NumPy array. I'm not sure how different, but there is a very subtle difference. Okay, so we learned column and we learned array. Now the point here is to change like the title of your columns. Sometimes you're not comfortable with the title, and I have to show this. For example, see there's one capital letter and you don't pay attention to it. You run this code and you will get key error. It's saying that there's no such a key in your data frame and you're not paying attention to this. Okay, so sometimes there is a need to, I remember there is a question in your quiz for previous quiz. I deliberately just changed the letter to be a capital letter and it's not working. So you need to be you need to consider that Python is sensitive to these things. Okay, moving on. So sometimes there is a need to change the name of the column. You could simply do that with this function, rename. Rename is getting old name and change it to the new name, and the structure would be a dictionary. So you give current names as the keys of your dictionary and later names as the values, and again in place true. In place true, so go change it and put it there. I don't want to copy it in another data frame. Just imply the changes. Okay. If I do that, see, revenue million is changed, runtime is also changed. So this is one way to do that. Another way is simply get the columns. What was the columns? Columns give me a list involving the name of the columns, and just change it to another list. Another way to do that. Okay, but there is a simpler way to do that. Can you just guess it? Do you have any idea? I'm not sure if you have gone through the tutorial or not. I'm just asking, curious. I want to change all the names to have lowercase, not to be capital at all.
There's a lower, I think it's function or method or something.
There's a method, exactly. There's a method, and if I'm going to generate that, I need to use list comprehension, like this. I need like I dot lower the method for I in movie df columns. Movie df columns is the list. I'm basically iterating over all the items in the list, and I'm asking the output to be lowercase. This is the output, okay? And I'm just saving it as my new column. This is list comprehension. You have dictionary comprehension, list comprehension, and it's very fast. Okay, there's another thing, how to work with missing values. Missing values is a very important topic in working and in working with any sets of data and data pre-processing, because they could be troublesome. They could make your learning method not acting well. So there's two approaches. One of them, which is literally too simple, is to eliminate all the rows or all the columns involving non-values. And the other one is called imputation. Imputation is to somehow give a value to the non-value, not just removing and throwing away all the null arrays, okay? So they basically use mean, max, or maybe median to just have a value, okay? First of all, we need to know where is the non-value. isNull could help us. isNull is a method that will show all the non-values in the data frame format as true. So there is a data frame of Boolean type, true, false, showing which cell exactly is null. So by itself, it's not very helpful, right? Because I couldn't see in a very big data set, I couldn't see what's happening inside. Something that could help me is to get a sum over isNull. If I do this, I can see there is 128 null values in revenue million. Also 64 in Metascore. So it's showing me that there is some rows with non-value related to feature Metascore. And I need to eliminate them, okay? So isNull by itself is not that much useful. And someone could please explain to me why the sum is not only a scalar value? Why it's giving me a value associated with each column? Any idea?
Is it because it's having a numerical, not a numerical value or something?
No. No. I was expecting maybe to see just a number, the addition of 128 to 64, otherwise they are 0. This is all because axis, remember? We went through it last time. There is an axis that these kinds of function are done over that. For default, this type of function, the default value is axis 0. So it means consider all rows and give me a sum over each column. Okay? If I changed it, like axis 1, it's going to be over all rows. And if I do this, I'm going to take a scalar, the sum of all the items, right? Okay. Suddenly, I'm too terrified that if it's recording. Do you see the record? Okay, perfect. Okay. So
Can you just
Sure.
show the syntax for the thing that you made the entire column as the lowercase? Right? Can you just show the syntax?
Aggregate them over rows.
Yeah, I.ch.
Just change the axis.
No, not this one. You change the first letter of the column to lowercase, right? I
Oh,
need
okay.
that. Yeah.
Sure. This is it. Lower or upper. Upper change to
Oh, okay.
capital and lower change to lowercase.
Yeah.
Okay.
Yeah,
This is the
Yeah.
function, and the whole syntax is called list comprehension.
Okay.
Okay. Moving on. So now how to drop null value? Just like drop duplicate, there is drop null. And you can use it. And I think it also has the in place true. I'm not sure. Yes, it also has in place true, just like the story we had before. So if you put in place true, it's going to change the initial data frame. Be careful with that. If you're not going to ruin your data, copy in another data frame, okay? So if I drop null, it's going to drop all null value, and it's acting regarding the axis, it's acting just like sum. The default axis is 0 here. So it's going to be all rows involving only one null. So it's eliminated. But if it was axis 1, it was over column. Got it? Okay, see? Now I end up with these number of rows. There's less rows because I told you any rows involving even only one null value is eliminated, okay? But here it's going to be over columns, and I have less columns. It's not suggested because normally people don't want to lose their features. They're okay with losing data rows, but not features. So don't do that. And one thing about when it's okay to remove a null rows, it is totally dependent on your data set. If you have a lot of data, a very huge data set, so it's not a big deal eliminating 10 rows. But if you're working with a small data, it's a big deal. And actually, it's also depend on your algorithm. For example, if you're working with a decision tree, it's okay. It's okay to do that. But for some algorithm, no, it's not desired to lose data. Okay. About imputation, I told you they're going to fill the null value with mean or median or whatever. There might be a particular function behind that, okay? But simplest thing is mean. So how to do that? Here I'm extracting a column, and I just want to see how many non-values is in my column. Okay. I told you if each column is a series, I can do the exact same things like head, tail, and etc. One other thing is mean. So the mean of revenue mean column is this number. Now I'm going to fill all the non-values with this input. Okay, so fill now is my function. Revenue min is the first input, what I'm going to fill with. And in place true, I'm telling that change everything. And this is it. Now, if I run this, there is no non-value here. And all non-value are occupied with mean. Okay. You could also see non-values in info. So is null, info, both works. There's another method, describe. Describe give you a very general understanding of distribution of each column. So you know that each column is a variable. They could be continuous, they could be categorical variables, but for these data sets, all are integer floats and so continuous variable. So I can see what is the mean, what is the standard deviation, mean, max, like all the quarters. So you could see very simple statistical analysis of these data sets with method describe, right? What else? You could do the exact same thing on a particular column because you're interested in information of only one feature, for example, which is genre. I would like to see this information. How many data it has, how many of them are unique. So it's very important information to know how many unique value I have in this column. And like the frequency of them, the type of them, and so on. And another interesting thing is to count the value. Now that I know there is only about 200 types of genre, but I have 1000 values. So what is the frequency? Because, for example, you're going to draw a histogram. So you need that. So this is how I get that. I'm telling this. I need this column. I need to count value, which is the function value counts. I wanted to see the first 10. It could be all of them. See? But the first 10 is more visible. Top 10 genre of this review. Okay? There is also a correlation function, which is very, very important. One of the very basic steps of when you're going to do regression is to see how variables or attributes or feature or predictor, anything they call it, how they are correlated to each other. Is there any particular relationship between them? Changing, reducing, increasing of one of them will lead to anything else? So is there any cause between them? So all of these you could find with correlation. And correlation is going to compare each pair, all features together, as well with the label. So if you face with a labeled data, I mean in supervised learning tasks. So you could also see the correlation of each feature with the output, which is the label of the data, class of each data entry. Okay. So this is all about correlation. Please go through all my description. They're very informative. I put some links for you, also documentation of pandas. They could be very helpful. Okay. And thank you for staying. We still have like a couple of, oh no, we still have a lot of time. Good. I thought it's 8:08. Now, move on with data frame slicing. As I told you, they are very similar with NumPy arrays. So slicing are somehow the same between data frames and NumPy arrays. And here, like this, see? I extracted a column. I know how to extract a column. And I told you the type of a column would be series. And what else? Yeah, it's a very interesting point. There's one way to extract. It's a trick in that there's one way to extract a column as a data frame, not as a series. If you give the column the input like a list. See? And what is the shape? I'm curious. It's like, again, two-dimensional, but here, what is the shape? It's supposed to be one-dimensional. Yes, see? That was interesting. Okay, so here I have a series as the output, and here I have a data frame as the output. It is important because sometimes you're going to do some like operation, numerical operation, or maybe a broadcasting, and you need to have two identical data types. Okay. This is how I extract two columns or more. I showed you before with the small purchase data. Okay. And also we could extract data by rows. These were all by column, how to extract one column, how to extract two or more columns as a list. Here, we need to extract rows. I told you there is two functions for that. Location, which is loc, and iLocation, which is iLoc. Loc is basically receiving the name of the index and giving you the associated rows. But iLoc works with the index. So we can see the difference as we move on. For loc, I'm asking, for example, I wanted to know all the attributes of movie Prometheus. I don't know. So this is what I do. Loc Prometheus. Prometheus is the title of movie. So what was title? It was the index of my data frame. Okay. So I'm giving it as an input to loc. And here I have all the feature associated with this movie, right? So this is loc. But if I wanted to use iLoc, I would use the position, or maybe the it's better to say the index number. Okay, so iLoc1 is related to the second row of my data frame. If I wanted to see prompt, it's here. See? So here I'm inputting the name, the title, the index, but here it's numerical index of the movie. I could also do slicing like NumPy with the same syntax. I need to have all the rows from this movie to this movie, and it's not going to consider the last like that this movie is not going to be in the output. See? So I can do that both with loc and iLoc. And this is the only important difference between these two. There's one more thing about how to select and extract information from your data frame, which is conditional, and it's very useful. For example, I'm going to extract all the movie reviews with the directory of Ridley Scott. Okay, so give me basically all the movies, all the movie reviews that is directed by this person. So it's a condition. This is one way to do that. I'm going to explain more ways. One way to do that is going through list. I'm iterating over the index and also the information for each movie. This is what itertools does. If it's complicated for you, or maybe you're confused with what itertools do, you could go through it, iterate it, and print the result to see what's the output. We have so many iterative functions in Python data types. One of them is iterrows, which is defined for like data frames. Okay, so I'm iterating basically over all the index and all the information, including all the features. And I'm putting a condition if director of these rows are equal to this person, append the title with this direction to a list that I defined before. Okay, so if I do that, and if I have my list, this is all the movies, okay, all the movies that is directed with the person I want. And now I can filter that with what? With the lock, because I have the index name. See? So I basically did this. This is my list. And this is how I extract data. And this is my filtered data set. All of them has this person as director. Okay? I could combine this condition with a lot of more condition, like the director, if the director is the same person and the rating is above like 7, or if the revenue is like more than 100, extract these rows. Okay, there's another kinds of writing this same syntax is to use list comprehension that I like it a lot. It is doing basically the same, but I'm just extracting title. So which title? Titles of the same director. I'm creating my list, and now I'm extracting the value. The same output. Okay. There is also very easier way to do that, to not create these lists, which is defining a condition. Very simple. Go through director feature, director column. Okay. Check each single value to be equal to this value or not. And then show me the result. The result would be a one-dimensional array, just as big as your column, with Boolean values. So it's saying that for the first movie, it's false. It's not this director. But for the second, it's true. So I have an array of the same dimension with my data frame, but including true and false. I have a condition. And very simple, I could filter my data frame with this condition. See? The same output. Okay. The same I did here. And it could be combined with more condition. Like here.
Hi, I wanted to ask like a doubt, like can we check the data without the ellipsis here? Like for example, if there are too many rows and it shows the 3 dots, right? In Jupyter, can we see the whole data? If you scroll up a little.
You mean if you don't like filter
Yeah,
by
for example,
no, to see all of them?
yeah,
No,
like
you
it
never
shows the
see
3
all of
dots,
them.
right? Never see. Okay,
No.
got it. Okay,
It
thank you.
has chosen to show you this way, just to pick some of them from the beginning and some of them from the last and put 3 dots.
Okay, got it. Thanks.
That's nothing. Okay, so here, see, I'm putting another condition. I could define the condition as a separate variable or not, giving it directly as the input to my filtering process, okay? So I'm telling that I need all the movie reviews for movies with rating greater than 8.6. There are a lot. There's so many of them. So I just want to see 3 of them. See? That's how it works. And you could use or, you could use and, equal as your logical conditions. Okay. Also, there's a good there's another good function is in. Is checking that go through director and check if the director is in this list. So again, it's a condition. The output would be array of true and false for all the movies with any of these 2 directors. Okay, so is in is like what it does. So the output would be Boolean. Another example, I don't want to confuse you. Okay, another thing that I really like is how to apply function. Sometimes you need to define a function based on the information you have in your data, and also maybe you could not do that, and also create a new column. For example, I would like to create a new column to divide all my reviews to 2 categories, because as you see, my data is only continuous. There is no label, there is no category, there's no class for my like data. I'm going to use classification algorithm, and I would like to know if a movie has a rating higher than 8, so it is supposed to be a good movie, otherwise it's a bad movie. I need 2 classes, 0, 1, good, bad, okay? So, and I have to generate a new column. This is how I define a very general function based on the rule I'm looking for. So I'm telling that create a function, receive the inputs, compare the input with 8. If it's higher than 8, return good. The value would be good. Otherwise, the value is bad. Okay? Now, with apply method, you can simply apply the function you just defined on a column. See what happened? This is my rating column. All the ratings for all the movies. And now I'm going to apply this function. So what is basically done, any of the item in the rating is going to this function as the input. And this is what I get. The array with the same dimension, including good and bad. And now with this line of code, I'm going to generate a new column, add that to my previous data frame, and give it a name, which is rating category. Good. So here, I have a new column. I have a new column for any single data. I have now a category, good, bad. So this function could be anything. Okay. There's also group by. Group by.
Sorry,
Sure.
is there any easy way of calling the function?
On calling function for what?
Yeah, is it possible to call the function without using the apply?
Yes. No, without apply, you cannot. You can call the function, but you need to give it an input. But if you want the function to apply on all the values in your data frame, you need apply method. If you call the function, you see my function. It's just like this. I use the function, I give a scalar because my input is only a scalar. And that's the output. This is what my function do. Assume if I'm going to do the same thing for all the data in my data frame, I need to iterate in a loop over all the data in my in the like arraying column and to have back the output. So they have designed a method that there's no need to do that. It's take a series and apply the function and give the output to you. So the function is as simple as that, only on a scalar, only on a simple and single input. This is, I think, the beauty of Plotly. Okay. Did I answer your question?
Yeah, thank you.
Great. So, for the people who work with SQL, there's a lot of group by functionality in SQL data, or I can say it's useful in any type of data pre-processing. What group by does is that it will, based on what you choose to group by on, for example, I here choose genre to group by on. So it's going to consider all the movies with the same genre, like all the movies that are action, all the movies that are action adventure. Okay, so it's group by everything, all the identical genre. It could be rating, it could be like, it could be even category that I just created. Okay, so I'm choosing one feature to group by on, and then I'm asking something, which could be anything, like sum. So I'm asking to aggregate all the revenue for a genre, for a particular genre. And this is the output. See, action has this much revenue. So group by is always doing some aggregated functionality. It could be sum, it could be min, max, anything that needs to be applied on a group of things. This is why it's called group by. Or for example, here I'm getting a sum over revenue of each genre, each identical genre, and I'm sorting them to see very important information, because I would like to know which kind of genre has the highest like revenue in total. Okay, so you can see that these operations, these functions are designed very simple. I mean, you could use this simply and they could give you very important and beneficial information from your data set. So it's very important to know these stuffs before working with any kind of data. You need to play with your data to understand it, and this is the way you can do that. Okay, I have some wrap up here. You could go through these like extra tutorial. There's a lot about pandas, but I tried to cover most of them. I also put some more practice here. This is basically what I told you just before. I'm not going to go through them again. Maybe this, for example, you can see all the unique values and so on. Okay, let's move on to Matplotlib package. Is there any questions so far, or so far so good?
1 second. About that dots that Python gives, I mean, the Jupyter gives, we cannot view the full column. Is there any function like I just surfed through there is a function called pd.options.display.maxColumns. In that, we can specify the number of columns that we want in order to display how many ever we want. If we give equal to none, will it display the entire thing?
Never worked with that function.
pd.options. Yeah, okay. So
Never worked with that. I can check that, but I'm sure you could define anything. I'm sure
okay.
you could, I'm not sure, it's better not to say this strong, but I remember I heard you could change the default of
Because if at all there is a missing value or an object in an integer function, if it's a binary value, I can just scroll through and just look at it and pinpoint the exact location and then define my. For example, if I'm looking for an index and it has no value, I need to look for that value. If I give I location, then I can use. If I'm able to see the entire thing, then it will be easier for me to do this. Yeah.
But
That was the best.
I still believe you don't need to see the entire thing.
Okay.
Yeah. If, for example,
It-
if it is null, there is no need to see the entire
Okay.
thing. Just
Okay. It
just if you do that, but actually, even if you do is null and you have the output as true false, you can simply filter to show
Okay.
all true values. And
Okay.
that's it.
Yeah.
Okay. So, and there's also something in chat. Okay.
Ziva, I think I have a couple of doubts. Like, can we read XML or HTML file from pandas? No, or no?
HTML from Panda,
XML or HTML, yeah.
or you're going to read
You told
data?
this on JSON is fine, but what about XML or XML file or HTML from the HTML file? No.
No idea. Maybe it's better to change the XML to JSON.
Okay.
There has to be JSON export.
Okay. And
I don't
this,
know.
can we create a global variable here in the pandas environment? Because you have everything you have created is a local one you're editing anyhow. Like, is it possible to create global variable?
Exactly. It's possible. It's possible.
What's the special command we have to use for the global variable if you want to make it like in the pandas?
I have to say, I told you before in NumPy, I assume the domain of a variable doesn't have anything to do with data type. You could define a functional variable, you could define local global variable in any type and with the same syntax.
Just see, I believe the global variable, if you define, you cannot edit that, right? Later on, you cannot change that variable. Am I right?
No, you can. It's all about the domain of the variable. I could send you like a
Okay.
description of how we define the domain.
Yeah.
If it's local to a function, if it's higher than local, and if it's global. We have 4 level, and
Yeah.
like for example, if it's a built-in, the last level is the built-in variable in Python. For built-in variables, even for built-in variables, you could rewrite them. You will
Okay.
ruin it if you rewrite them, but you could do that. So all of them are editable.
Okay. Because I don't know whether any command is here in Python where some of the variables you can't touch it up, like, it's kind of
Exactly. The point that you're mentioning is that there is some variable like built-in variable in Python that there's if you do that, if you rewrite them, you basically change everything, and you're going to find a lot of error afterwards.
Okay.
But it is changed and you understand nothing on the spot.
Okay. Thank you.
Unless some of them may give you an error. Okay, so going through Matplotlib package, which is basically for having data visualization, to have some very beautiful charts. I have there is very comprehensive tutorial on them in the internet. I believe a professor shares some link with you. It's actually impossible to have all of them here. I just put some important example of main type. So for Matplotlib, which is I told you it's a plotting library, and the more beautiful package is Seaborn, that it's on top of Matplotlib, but it's indeed more beautiful. Matplotlib is ugly comparing to that. Again, importing the library. After that, you need to do like you need to define your axis. For a two-dimensional plot, there is two axes basically. The first one is the x-axis, and the latter is the y-axis. That are your outputs in 2 dimensions. Plot is giving you a line, and plot show is for just not seeing the output shown by default. I'm just with plot show, I'm just showing only the plot. So I have the x-axis. These are my numbers. I didn't define it previously. I just give it as the input and my values. So these are only 4 dots. And because I'm plotting a plot, it's going to be a continuous line. But I could do the same thing with the scatter. If I change it to scatter, you could see these are only 4 dots. But with plot, it's a continuous line. I also plot a scatter plot for random number. So I'm creating 50 random number from a uniform distribution because it's rand n. And I'm just plotting them in a scatter plot, something like this. Okay. The other plot that is very useful is how to have a histogram. Plot.hist is the syntax for histogram. And so first of all, I'm creating my data points. I'm using mean 0 and standard deviation 0.1. I'm creating 1000 random number from this normal distribution with the same mean and standard deviation. So the first input, mean, second, standard deviation, and the size. So I'm just in these 2 lines of code, I'm creating my data set, and then using histogram plots, I'm plotting the histogram. And as you see a red line here, I'm also using a plot because that's the standard normal. That's a normal distribution, and I know the function of a normal distribution. So I also generate the line for a standard distribution and have it both together. So it's my histogram and it's the red line showing the function of a standard distribution. Okay, now we can add more information to our charts and make it more beautiful. Like what? Like the title for the x-axis, like the title for the y-axis, and also the title for the whole diagram. Okay, so these are the line of code. I need title to be this. I need label for my both axes to be this. And also I wanted to save my picture in the directory that I have. Okay. This is what it is. Another thing that is useful is how to generate subplots. Subplots in a row or subplots in a columns. I I rarely seen subplots in a column, more in a row. So this is it. I still needs my x-axis, and also I have my values for y-axis. The only different thing here is that in the first plot, I have a bar plot here, and then a scatter here, I'm sorry, and then a line plot, okay? So, but the values are the same for all of them. If you're going to have a subplot, you need the exact same code. First, you can define the size of your picture, your figure. You have to define your subplot position. What this means, it means that there is one row and 3 columns for my subplot. This specific plot is going to be on the first position, my scatter in the second, and my line plot in the third position. Okay? And also, so 1 row, 3 columns. I could have 3 rows, so it should be 3 in all of these 3 lines, and 1 column, and 1 in these numbers, okay? And also, I need a title for all 3. This is the output. Okay? Seaborn is doing, I can say the very similar thing, but they have enhanced literally the weight function. It's really better, more flexibility with Seaborn. And there are numerous type of figure that I don't know any of them by heart. I always want to plot one of them. I just Google what I need and it showed me. But going through the documentation of Seaborn is very useful because it will give you an idea of which kinds of plots it has. Okay. Now I import Seaborn package as SNS. I have a data frame, which is tips. I'm loading this data set from a link. This is the information for my data set. And what I'm going to do, that it's very complicated, and you couldn't do this as easy as here with Matplotlib, but Seaborn is doing for you. I have a bill value, and I have a value for tip, and I want to know if there any difference between a smoker and non-smoker. So I'm going to divide all my data in 2 types to see how they could, like, for example, create a cluster together. And I know there is a connection between tip and the value of the total bill. It is simply showing that if total bill is increasing, the value of the tip is increasing. But I would like to know the impact of smoking and how much they tip. Do smoker tip more than non-smoker? So it's simply done by this syntax. I have my X, I have Y, like Matplotlib, and a parameter named Q, and my data as the input. And this is the output. Okay, I'm so glad that we could finally finish Pandas. Apparently we go fast. So I'm going to stop recording right now. If there's any question, I would be happy to answer. Otherwise, we can leave. So don't forget to go through all the documentation and all the description to be prepared for the next quiz.
Thank you. Have a good night.
You too.
Bye-bye.
Bye. Great, so I'm ending the session.